Do you find ghosts scary? Well, have you thought that it's also a law in physics? It's called the Gauss Law. Get it? But Gauss what? This law is not something to be scared of. In the 19th century, Carl Friedrich Gauss, originally Johann Carl Friedrich Gauss, formulated a law that relates electric fields at the points on a whole surface and the net charge enclosed by that surface. This law tells us in nature that there is a positive electric charges and negative electric charges. These two electric charges can interact with each other without touching each other through the lines that we call the electric field. By convention, we can say that the electric fields are directed away from positive charges and towards the negative charges. Also known as Gauss-Flox theorem, it comprises one of the four Maxwell's equations that describe the force of electromagnetism. Much more laws help this Gauss law, but as for now, we'll focus on Gauss law only. Flux is a measure of the strength of a field passing through a surface. Electric flux is defined in general as phi is equals to Q over epsilon 0. Phi is the electric flux through the surface. Q is the charge enclosed by a surface. Epsilon 0 is the permittivity of free space, which is just a constant that is always equal to 8.85 times 10 to the power of negative 12. In a field, we can view a rod being present. The rod acting as a negatively charged rod, field lines in the electric field are drawn in and moved towards the rod. If a charge is placed near between the field lines, then we can expect the charge getting most of the magnitude. Therefore, the amount of magnitude being received is proportional to its electric flux. But what is electric flux? It's basically the number of field lines that passes through a surface. The more field lines, the larger its flux. Phi is equals to EA. Since flux is also equal to the electric field multiplied by the area of the surface, so EA is equals to Q over epsilon 0. Example, for a sphere, the surface area is given by 4 pi r squared, so we can plug that in for A. And finally, if we rearrange for the electric field E, we find that the electric field E is equal to the Q over 4 pi epsilon 0 r squared. This is an expression for the electric field created by a charged sphere. But not all surfaces are spheres, so the exact equation for the Gauss's law varies depending on the particular surface you're looking at. In a conclusion, the total of the electric flux out of a closed surface is equal to the magnitude of the charge enclosed divided by the permittivity of free space. The application of Gauss's law in real life is not visible to the naked eye, but if you're eager to learn, you can see how electricity moves through spherical surfaces. This is Pearl Saragossa teaching you all about the Gauss's law. Keep safe and God bless. Bye!